Hi, thanks for checking out our video. This is just a little show and tell video of this particular unit. This is an old MPE model made by Gallagher. This is probably a late 70s, early 80s model, somewhere in that range. In like mid 80s, they came out with the MPE2, which was a more compact version, a little more square shaped. Um, Gallagher had a few units that had this shaped case. They had about 5 or 6 probably that they sold here in the States of this kind of case design. So we're going to go through it. It's working. It's working just fine. Nothing really wrong with it. We did have a video of how to test it, anything on going through it, testing transformer output and the capacitor and all that stuff. So I'll put maybe if I can remember, put a link in the description on that one. Try to remember. But anyways, if you've got a fence charger of some sort and you want to send it to us to work on, be happy to take a peek at it for you. We do give free quotes. There are links down below in the description area of our websites. We also work in cattle scales and low bars, so Cattle Scale Repair is the website for that. But you're welcome to call, text, email me questions, and if you've got one that's not working right, instead of fooling around with it, just box it up and ship it here. Let me take the case off real quick. Show you the inside. Nice thing about these old ones like this, everything's all separated, so you kind of can, if you know how a unit works, you know, just follow the path and to figure out where the problem's at. If you know how a fence charger works, kind of show you how it works a little bit, since this is everything's all separated inside. Okay, how this one is set up. You got a main board here, a big capacitor here, your output transformer here, and this has an output board for lightning protection as well, right here. What this output board does is it takes the power from the transformers and hooks onto the fence and ground. But it also has down inside this big white resistor right here. That's just a voltage divider to split the load between this, because this has a half power setting on it as well, so it's full on half. And that's what that yellow terminal is for. But that's what the resistor does. It just divides it down to give the customer the half power option if they want to use it. Most people I know never used half power, even when they could. They never did. Alright, so how this works, power comes in here, gets onto this board. Comes in AC, but through this capacitor and some other stuff, it turns it into a DC voltage. And this capacitor will gradually build it up, and it gets over to this big capacitor. And it comes in probably between, I would say, 400 and 800 volts or DC is usually what's across capacitors. Now every brand and size is different. Some of the small ones are lesser volts, some of the big ones are higher voltage, but these between 350 and 800, 900 volts maybe on the higher side. But anyways, gets onto there, and there's a device on here, usually this one. There's some other things that do it too, but there's a timing circuit in there that tells it when to fire, every second or two. This device here is the firing mechanism that fires this capacitor, takes that, say, 500 volts DC, discharges it. It goes into the transformer. The transformer takes that, say, 500 volts DC and high current, spikes it up to, say, 6, 7, 8, 9,000 volts DC, and outputs it to this board. This board takes it and gets it onto the terminals. This board's not really a necessity to have. It's a lightning protection board more than anything. But so if this board was bad, we could get rid of this board, take these 2 wires here, and hot wire it right to the fence and right to the ground, and just get rid of this board altogether. They'd lose their half power, but nobody really cares about that anyways. And you might gain a little bit of voltage. You might gain an extra 1,000, 1,500 volts maybe out of it. But the capacitor was good in this one. It's the old style. It's probably the original capacitor. I don't know what they call them. I always call them the double hump. It looks like 2 capacitors that are pushed together, glued together. But it's the newer ones. Let me go grab a new one. There's a 30 microfarad, like 900 volt capacitor, something like that. this is what the new 30s look like that they came out with 25 years ago, 30 years ago. Different colors. If you have blue, gray, white, beige, but they're all this size now. The 30s are all this size. So you can see it's more compact and smaller, but does the same exact job this bigger one did. So as time went on, they made capacitors better, especially for electric fence applications, fence chargers on low impedance stuff. Everybody, started going to this style. And as time went on, they got better and better and better quality control and manufacturing and made them better. But this one I think is original because they haven't made them this way since back then. So this is probably a 30, 40-year-old capacitor, but it tests perfect. It tests perfectly fine. And all the way that flow of how the electricity goes through and clicks and pulses, it does all that in about 1.5 seconds, or every time it pulses. So it does it every, within an amount of time it does all that stuff. So you see it's a pretty loud unit when it clicks, because the loudness of the unit doesn't mean how strong it is, because this is about a 2 to 3 stored joule unit, so probably 1.5 output, something in that range. But the loudness comes from the transformer. This particular one has these metal plates right here. They're kind of exposed and outside, but down inside is where all the core and everything is, and it's all encased in epoxy. But the reason why it's so loud is because the metal is exposed. If this had been a transformer that the whole thing was encased in epoxy, this was metal plates were in epoxy, it'd be a little bit softer, quieter unit. And again, now all Gallagher's units, well, not all of them, from like the 15 joule and smaller, all their transformers are the transformers metal plates, and they're all encased in epoxy, so they're a lot quieter. Now it also helps the transformer last longer because everything's encased in epoxy and can't break apart prematurely unless lightning burns them up. But it's pretty quick. I mean, all that stuff I was talking about, how it goes, it does it in between those two pulses, so every half a second or less. This also has a light there at the bottom that flashes with every time it pulses and clicks. That's pretty slick. And we'll test it. These were one of the lower voltage units that they made. Even the MPE2 was about 4.5, 5 kV. This puts out just a little over 5. But most brands, voltage-wise, float between 5,000 and 10,000 volts, between that range. But on average, between 6 and 9 seems to be average for most brands. There's not very many brands that go over 10,000. They do, they're either meters reading them wrong, it's not calibrated right, or it's not UL standards or whatever, because they're not supposed to go over a certain amount of voltage, because then you're eventually going to break through the insulators, especially those cheap yellow ones. Eventually start breaking those down and arcing through to T-posts and stuff like that. So we'll put a little screwdriver or needle nose across to show you the spark it jumps. Somewhere you can see it better. So a nice little spark from it. Not super stout, like I said, it's about a 1.5 output, give or take, joule unit. Probably 2 to 3 stored. It's a pretty hefty sized unit for the power you get. Now you can get units that are 2-3 joules and half the size case as this thing is. But they share the same case and set up, just different parts in it on a multitude of units, models back in the day. About 5 or 6, 7 of them that I can, probably 4, 5, 6 that I can think of. So hopefully you like this kind of stuff. We got a bunch of videos on YouTube, so you can go check us out on there and search us up for a particular model or make or whatever. If I got a video on it. So if you want to send us something for us to work on, be happy to do it. We give free quotes. We work on all brands and ages of these things. This thing's 40-something years old, or 35 to 40 years old, and it's still working. So until next time, we'll see you guys later on, and have a good day.